and that was it. So we're going to start right here with number 9. And we're kind of in the middle of chapter 4. If you look at your outline, there is, speaking of the outline, there is something that I wanted to point out on here where it says finding indefinite integrals, which is what we're doing right now. Underneath of that, it says no inverse trig integrals. I think we only had 2 of them maybe that we talked about. It was like arc sine and arc tan, if I remember correctly. But those are not going to be on the final. So just pointing that out for whenever you start to make your cheat sheets. What will be on the final, though, are trig integrals, e, which I think we had a little bit yesterday, natural log, u substitution, all of that stuff could show up. So speaking of u substitution, that's probably what I want to do right here with number 9. I'm not allowed to distribute the x. If you wanted to rewrite that square root as x plus 1 to the 1/2 power, you could, but still you're not able to distribute, which means this integrand is not very rewritable, so we should probably try the u substitution and see what happens. This is a very good review problem for the final. So I'm going to let what's in parentheses or under the radical equal u. du is actually just 1 dx. Now, whatever you have over here should match up to what you have over here. I know the u part is taken care of, but for du, all I'm supposed to have is 1 dx. I don't just have 1 dx, I have x dx. This is the time where we have to do something a little special because there's an extra factor of x in our integrand. Do you remember what to do or what this is called? Yeah, basically this is what we call the change of variable. Anytime you have that extra factor of x, you're going to have to come back over here, solve your u substitution equation for x. So imagine just subtracting 1 from both sides. That would leave you with x equals u minus 1. So wherever I see x over here, I'm going to replace it with u minus 1. I'm getting a lot of colors going on up here, but this is what it turns out to be. Instead of x, it's now the quantity u minus 1. And this, I can go ahead and rewrite that as u to the 1/2 power, bless you, du. Now, at this point, we can distribute to simplify this a little bit. If this is u to the 1st power, and I'm taking u to the 1st times u to the 1/2, I'll have to add my exponents. And you may even want to think of the 1 as 2 over 2. So 2/2 plus 1/2, that would be u to the 3/2 power minus u to the 1/2 times 1 is just u to the 1/2 power. Now keep in mind that you have not integrated yet. This is still just simplifying. Now I'm going to integrate. Add 1 to a 3/2 and you'll get 5/2. So it's like 3/2 plus 2/2 minus, over here, add 1 to your power. Put your new power on bottom. Now I'll try to kind of do all the rest of this simplifying in one step. That is going to flip and become 2/5 times, I'm not going to leave it as u to the 5/2 power. I want to go back and put in what u was. So now it's 2/5 times x plus 1 to the 5/2 minus 2/3 times x plus 1 to the 3/2, and then just plus c. That would be it. Again, if you do the u substitution and you have an extra x, or it might not just be x. Remember, I think sometimes we had something different, like maybe x squared or x minus 2, something like that. You could get that from this equation. If this was an x squared, then I would just square both of those. And then that would give me whatever that is foiled. That would give me what I need right there. I'm going to erase that because that's not really what we did. Any questions about number 9? Change a variable. It's going to be on there. Now, let me go ahead and run through, I think just two definite integrals. And these are just the ones where they give you A and B. This is number 10. And it says that we are integrating from 1 to 2, and it's x minus 1 over x squared dx. All right, I'm not going to worry about the 1 and the 2 until I get everything else done. So first thing I notice, 1 over x squared, I probably want to rewrite that as x to the negative 2nd power, just pulling that up to the top. I don't really like it in fraction form. So now I should be able to integrate. I'm going to add 1 to my power. This is like x to the 1st. So x squared over 2 minus, this is always kind of tricky with all these negatives. If I add 1 to negative 2, what do I get? Negative 1. So you're subtracting x to the negative 1st power all over negative 1. Now, this is not 0, this is 1 to 2. I probably don't want to plug anything in yet until I get this simplified. So first thing we could do is change those two minus signs to a plus sign. So that helps. Now when I move that to the bottom, I could probably just leave a 1 on top. So actually, that makes it look quite a bit better. Now I'm just adding 1 over x. So which number do we plug in first? The 2. Yep. So I get 2 squared, which is 4 over 2, plus 1/2, minus, I'm going to plug in the 1 now. In parentheses, I'll put 1/2 plus 1. So, I mean, this is like a 2 right here. And by the time I distribute that negative, when I distribute it to this, 1/2 minus 1/2 is just going to drop out, but I will still have minus 1 right after that. So, of course, 2 minus 1 would just be 1. Okie doke. Remember definite integrals, you can check on your calculator, which might be especially helpful on a multiple choice test. But keep in mind, some of these integrands might be kind of hard to type in. So make sure that you know always which bound to plug in first. Upper bound minus lower bound. Okie doke. Let's try one more of these. And it has a little trig. It says we're integrating from pi over 4 to pi, I'm going to use handy dandy for this, it's 2 secant squared of x dx. Now, the 2 can pretty well stay out front. And anybody remember what the integral of secant squared is? Tangent, yeah, just plain old tangent of x. So that's all it takes to integrate. Now it's just a matter of plugging in my bounds. So I'll plug in the pi first. 2 tangent of pi minus 2 tangent of pi over 4. I'm just going to use handy dandy real quick to evaluate these. You will get a handy dandy on the final if there are problems like this. But tangent of pi, using that big table at the bottom, tangent of pi is actually 0 minus 2 times tangent of pi over 4, which is 1. So by the time I take the 0 minus 2, I'll just end up with negative 2. So that's it for number 11. You probably could use your calculator to type this in. Just make sure that you are in radian mode when you do that. My trig classes have been in degree mode lately, so if you're using one of my calculators, chances are it's in degree mode. That doesn't have any degree symbol, so you'd have to be in radians. Okie doke. Stop me if you have any questions. I'm going to just keep on moving here. One of the last things in the chapter 4 section is sigma notation. So we're going to try one, I believe, of those. Remember, sigma notation is just like a sum. Sometimes it's called summation notation. And it says we're adding from I equals 0 to 5 of 2i plus 1. Basically, this number down here at the bottom is what you plug in first. So I'm going to be taking 2 times 0 plus 1. I'm going to maybe put that in parentheses so you can see it better. That is just this expression with the 0 plugged in. I have to add to that the same expression, but with every other number after 0 to 5. So I'm going to go with the 1 next. 2 times 1 plus 1. Then I'll go up to the 2. 2 times 2 plus 1. Ran out of room. Plus 2 times 3 plus 1. Plus 2 times 4 plus 1. Plus 2 times 5 plus 1. The number on the bottom is where you start, and then you plug in every other number until you hit that one, the number on top. So that's the last number to plug in. Now, 2 times 0 is 0. 0 plus 1 is 1. 2 times 1 is 2. 2 plus 1 is 3. This would be 4 plus 1, which is 5. 6 plus 1, which is 7. 8 plus 1, which is 9. 10 plus 1, which is 11. It's like I'm adding up a bunch of odd numbers. So 1 plus 3 plus 5 plus 7 plus 9 plus 11. That gives me 36. You can probably type that into your calculator earlier, but I like to avoid all the parentheses if possible. Okay, on the outline, all it said was writing and using sigma notation. This would be just using sigma notation. We also had some problems in our notes and in our homework where they gave you this part, all the stuff that you're adding up, and you had to turn it back in to sigma notation. That's also something that could show up on the final. So what we did there was just basically using it. Okie doke. Now, this should be the last thing that we're going to review here in chapter 4. Free-falling objects. There will be at least one, maybe two, free-falling object questions on the final. And I've got this on the study guide, but it's also up there. You will only have to be in feet per second. And I'm going to put the formulas back up here in a second too, in case you're making your cheat sheet right now. But velocity and height, those are the two formulas that you'll need. You just don't have to worry about it in meters. So just feet per second. And here they are. Velocity, v of t, equals negative 32t plus v sub 0. And the height was always the s of t formula. And that is negative 16t squared plus v sub 0t plus s sub 0. All of the little subscripts there are initial values. So the v sub 0 is the initial velocity, and the s sub 0 is the initial height. So we'll have to kind of take these problems and figure out what they've given us, figure out what we're trying to find, and then kind of go from there. We'll just start by plugging in whatever we can. Only feet per second. So I'm going to put an example up here, and I'm only doing one example, but this might be an area that you want to go back and look at your notes a little bit more, because there were a couple other different types of problems. But this one says a ball is thrown upward from a 200-foot building with an initial velocity of 20 feet per second. How high will the ball go? Okie doke. I'm going to start by just kind of listing the different things that they've given me, and then I'll start to kind of plug it in and see where to go from there. This problem is asking for height, how high it's going to go. The other type in our notes was where we were trying to find what the initial velocity was. That's something else you might want to go back and review. But if the height that I'm starting at is 200 feet, then that would be s sub 0. We're just going to assume it's starting right on top of the building. And then initial velocity, they're telling me right there, 20 feet per second. Now, just to kind of get us going, I'm going to take those two formulas that I gave you earlier, and I'm going to start to just plug in whatever I know already. So it doesn't really matter which one you go with first. But if you take that height formula, it said negative 16t squared plus v sub 0, which is 20t, and then plus s sub 0, which is 200. S of t is what I'm trying to find in this problem, but the issue is we don't know what t is. We don't know how much time it takes for the ball to reach its maximum height. So to help us find t, I'm going to go for that velocity formula, which said negative 32t plus v sub 0, so plus 20. Now, if we're talking about the ball being thrown upward, it has an initial velocity of 20 feet per second, But once it reaches its maximum height, how much velocity should it have? Is it going to keep going up? Yeah, it's not going to have any more velocity. It's done with that. And it's going to have a velocity of 0 because right after that, it'll go back down toward the ground. So we need to set that equal to 0. And this, I'm subtracting 20 right here. But this is how we'll solve for t. Okie doke. Negative 20 divided by negative 32. I get back 0.625. Doesn't even take a full second to reach its maximum height. So that's not my answer, which actually, if you were doing the recommended review problems, this was like number 11, I think. But anyway, one of the questions with this problem in the review was how many seconds does it take? That would be your answer for that type of problem, whatever you get back for t. We don't really care about how many seconds it takes. We want to know how high it will go. So take that, basically just that right-hand side, and everywhere you see t, plug in 0.625. So plus 20 times 0.625 plus 200. I'm going to try and type it all in at once. So negative 16 parentheses 0.625 squared plus 20 times 0.625 plus 200 doesn't go a whole lot higher than where it started, but I get back 206.25 feet. So really it only went up 6.25 feet further than where it started. Okie doke. Free-falling objects. Any questions about that? Again, look back at your notes from that section. Even the ones that were in meters, you're not going to have meters on the final, but the way you do those problems could show up again. Again, the example I mentioned earlier was the one that asked for initial velocity. There's kind of a different way that we did that. I'll leave that for you. Now, starting with chapter 6 here, this is the last chapter that we had. I will do a few examples, but then probably what you really want to see from this chapter is your twist that we took. So I'll pass those back today also. But let's try one asking for area. You can write down whatever or however much you want from those directions. But main idea with this example is we're not finding volume, we're just finding area. Pretty much whatever you put on your cheat sheet for this last quest, I would probably want to put back on my cheat sheet for the final. Remember, the final cheat sheet can be two-sided, full page. You'll turn it in after day 1 and get it back for day 2. Alrighty, this is number 14, I think. Haven't really been keeping track, but I guess that's right. Number 14 says y equals negative x squared plus 2, and then y equals 1. It's multiple choice, so the graphing part is not going to be something you have to do. If it helps you to graph it so you can see what's going on a little bit better, then do it. But again, it's multiple choice, so I'm not really going to care if you draw the graph or not. Now, this should actually be a parabola flipped upside down and shifted up 2. So I think I can get this real quick here. And the only other function is y equals 1. That's just a horizontal line at 1. So this right here is our bounded region. We want to just find the area of that region. So again, on your cheat sheet for the final, I would put back on there whatever you put for the last cheat sheet that we had. For area, we had some probably in our notes where we were finding area, but we were integrating with respect to y. We're only going to have with respect to x on the area problems, so don't worry too much about that. I would say for my bounds here, -1 to +1, because I'm thinking of x values. Now, for area, does anybody remember the order of the functions? Something minus something. Top minus bottom. Yeah, if you want to write that down, you might want to. Top minus bottom. So function that forms the top part is -x² plus 2 minus function that forms the bottom, which was just that horizontal line at 1. So I'm just going to subtract 1. Now we may go ahead and simplify that a little bit before we integrate. -x² plus 1 is what it simplifies to. So add 1 to your power, put your new power on bottom, plus, if I integrate 1 with respect to x, it's just x. And I'm going from -1 to +1, but plug in the +1 first. So 1 cubed is 1, but I still have to make it negative. So plugging in the 1, I get -1/3 plus 1 minus, now I have to plug in the -1. Be careful, -1 to the 3rd power is -1, but then the other negative is going to turn it positive. So that's just a 1/3, and then -1. Plug in a -1 to that second part. So you can type this in if you want to. It'll end up being -1/3 plus 1 minus 1/3 plus another 1. And I think you'll get like a 1.3 repeating. I guess we did units squared for area. So that's fine. You don't have pi with area. It's just a plain old 1.3 or 4/3. Either way. Okie doke. Now I'm going to switch over here and try 1 using the disc/washer method. And I know these directions are kind of long, so if you want to shorten them up, I would just put those parts that I underlined in red. For the next example, we are using the disc/washer method, and we're going around the x-axis. Those are the 2 main things that you need to pick out from your directions. So first question, what variable am I going to integrate with respect to? X. If you are going around the x-axis with the disc method, you integrate with respect to x. Shell method here in a second is always the opposite. So we'll review that here in just a minute. So only one for the disc method. We've still got a shell that we'll do here in a second. But it's got y equals 2x squared, x equals 3, and y equals 0. Again, it's multiple choice, so if you do the graph, great. If not, I'm not really going to care either way. But I like to graph just so I can see exactly what's going on. I know there's going to be a vertical line at x equals 3. So when I draw my parabola, there should be a point at the origin with that parabola. But think about what happens at x equals 3. If I plug a 3 in right here, 3 squared is 9. 9 times 2 is 18. At 3, my parabola is all the way up at 18. So I'm just going to fib a little bit on my y-axis. Y equals 0 is another function. So this is the graph that I'm working with, and I'm going around the x-axis. Now with the disk/washer method, should the rectangle be parallel or perpendicular to that? Perpendicular, yeah. So since our axis is going horizontally, I'm going to draw my rectangle more vertically. Okay, next question, do I want pi or 2 pi? Pi, yes. And again, we're integrating with respect to x since we're going around the x-axis. So we're going to pick 0 to 3 for our bounds. And if you look at where the rectangle is, it is right up against the axis of revolution. You don't need the washer method, you only need the disk method. And for that, we basically take our function, which was 2x squared, and we square it. Now, we may have had something similar to this on a quiz, possibly. What do I get if I square 2x squared? Careful. It's 4x to the 4th. I can't remember which test or quiz it was, but I do remember some people putting, we'll see you later, some people putting like a 2x to the 4th. You always have to square both parts. So keep that 4. Now, integrate. I'll keep the 4 either out front or on top. So adding 1 to my power, putting my new power on bottom. I'm looking a little bit like that. So taking it from 0 to 3, I'll plug in the 3 first. 3 to the 5th power, yikes, that's 243. Take that times 4, and so you can leave it as 972 fifths pi, or if you wanted to go ahead and divide that out to get a decimal, it's like 194.4 pi. Either way is fine. Now, if the choices on the final have fractions, but you got a decimal, just take the choices and divide them out on your calculator and see which one matches up to what you got. 972 divided by 5 is the same as 194.4. Okie doke. Now, one last one here using the shell method. Again, you don't have to copy all those directions down as long as you have those 2 parts in red. We're going to try the shell method, and we're going to revolve around the x-axis. Shell method, revolve around the x. So what variable are we going to integrate with respect to? Y. It's opposite with shell method. Because of that, we will have to work on our functions a little bit since they're not in terms of y. Here it is, last one, number 16. Y equals x squared. X equals 0. And y equals 4. I like the fact that they have y equals out front, especially this one, while I'm graphing, because then I know exactly what it looks like. The first one is just a parabola. I'll put a point at 0, 0, 1, 1, 2, 4, and I'm going to cut it off right there because y equals 4 was another function, and so was x equals 0. Okie doke. Nope, I'm not going around the y-axis, I'm going around the x-axis. Gotta put my arrow down here. You told me earlier with the disk method, your rectangle is always perpendicular, but shell method, we're gonna be parallel. So I'm gonna draw it like this. And, okay, here I go. Volume equals, if you remember our formula, there has to be a 2 pi out front, not just pi anymore. Now the bounds here. We're going around the x-axis, but that means we have to integrate with respect to y. So 0 to 4 should be our bounds, not 0 to 2. That would be if we're going the other way. Okie doke. Now, the part in here was always y times f of y. And remember with the shell method, f of y is the height of the shell. If the shell was going this way, it would just be whatever the function was on top. But now that our shell is kind of on its side, the way we get f of y is always function on the right minus function on the left. However, I'm integrating with respect to y. So I actually need to solve that for x, and don't worry about the plus or minus. We want volume to be positive anyway. So the function on the right is not x squared. I want it to just be square root of y minus the function on the left, which was just 0. So I'm going to be putting square root of y in for f of y. Now, simplifying that before I integrate, if this is y times square root of y, it's like taking y times y to the 1/2 power. So 2 halves plus 1/2 would be 3 halves, but I haven't integrated yet. That's still just me simplifying. Here we go. Keep the 2 pi out front. Now it's going to be y to the 5 halves over 5 halves. So I'm just going to keep the 2 pi again out front while I make this part look a little bit better. I just turned that into 2/5 y to the 5 halves power. Plugging in the 4 to the 5 halves is 32. And then 32 times 2/5 is 12.8. I'm also going to take that times 2 from the 2 pi. So finally, I don't have to worry about the 0. I'm going to just get a 25.6 pi. That would be our volume. Okie doke. So that stuff, probably disk method, shell method area, that stuff is more likely to show up on part 2. But either way, remember your cheat sheet can be double-sided in your own handwriting, made up before class, no photocopies, all that stuff. You've got a little bit of time left today. I'll get those tests passed back to you. But also you'll have time in class on Monday to work on cheat sheets and review problems. So I'll make my way around here.